So, while talking about CosmWasm, it is basically a contract platform based on Cosmos ecosystem. So, as the name suggests, it's derived from two words, Cosmos as well as WebAssembly. So, shorting it down, it is basically a module that is written in Cosmos SDK that is supposed to interact with blockchain through smart contracts. The smart contracts are basically written in Rust, and which is a prerequisite to start any development on CosmWasm. So let's look at the brief architecture of how it actually looks, where you can see that in this particular diagram, there are different modules with name like auth, gov, staking, slashing, and so on. And there also exists a WASM module, which is having like WASM VM, which is encapsulated with libwasm VM and WASM. So this is supposedly meant to interact with smart contracts, and these different modules can interact with this WASM module as well. So, while talking about how Cosmos SDK uses CosmWasm and how CosmWasm code can go through different functionality, here are three major functionality that a CosmWasm contract actually works on. So most of you must be familiar with how contracts on Solidity and Ethereum side work, where you have a Solidity file where which you compile it and then deploy it. And based on your deployment, you can just create an instance of particular deployed code. Same in this case as well. It works in the same fashion where we have a WASM file that is actually optimized after your contract is completed, and then once you have actually optimized it and created a WASM file for it, you are supposedly supposed to upload that particular code on the blockchain. And since that particular code is just a bytecode and has a no instance for it, here comes the instantiation contract functionality where you need to provide some initial state to that particular contract, and based on that particular state of contract you can interact with that particular contract using the execute transactions. So, and things to be noted that suppose you have one code which you have actually uploaded in the blockchain, you can create as many instances as you want, and each instance will have its own state variables. So let's try to understand like its comparison with Solidity. So as discussed a few minutes ago, like the instantiation as execution of all the contracts in Solidity as well as Rust works in the same fashion with the metered gas that actually required on the both of sides. Few of the differences I would like you to know that uh, in Solidity and in Ethereum side, you must when you are actually sending few tokens, you are sending those tokens through a smart contract, uh, be it like the ERC20 token that actually manages the flow and minting transfer of that particular token. But here in this case, we actually have a bank module which is responsible for interacting with the blockchain for sending or receiving any token-based transactions. So now let's look at how Comdex uses CosmWasm. So our current mainnet is a permissioned one, where every contract that is deployed on our mainnet is going through a governance proposal where the deployer needs to provide their where the deployer actually needs to create a governance proposal, and based on the community voting it is decided whether that particular contract has to go to the chain or not. And context of this hackathon, we are actually keeping a permissionless CosmWasm on our chain so that every developers can upload their code and interact with it permissionlessly rather than going through the governance proposals and the similar functionalities. So governance contract so basically there are two different major contracts that Comdex uses from the CosmWasm. The first is like the governance contract, and the second one is like the logging contract. So let's get to know about it in a briefly. So governance contract is basically a CosmWasm contract which actually manages the governance of Harbor protocol. So Generally, we do have a Cosmos SDK governance module as well, which can affect the parameters of any governance based proposals. But in the Harbor protocol, we are going with the CosmWasm governance, where every parameter, whether it's an auction or whether some vault has to be minted or not with any pair or not, actually goes through this Harbor protocol governance. And we actually have users who can vote on that particular proposal through their voting power. Now, here's an interesting thing that the voting power comes from V Harbor, that is generated when someone having a Harbor token actually locks their tokens in locking contract, which then gives you the V Harbor voting power to actually cast your vote on any governance proposal for Harbor protocol. So now, before starting to interact with CosmWasm and testnet, there are few prerequisites that we actually need to have on our system in order to interact with them. So let's look at them. So we'll go to Dora Hacks, Comdex Hackathon details. And in the developer resources, you'll find the Hackathon instruction guide. So let's get over it. So the first and foremost requirement is a Go installation as well as a Rust installation. So would request everyone who is seeing this workshop to have this pre-installed in your system before starting development on any CosmWasm based project. So once we are actually done with installation of Go and Rust, we can verify our installation as well. So I can just see my Go version, which is 1.19. Now, we actually need to install complex binary, which is the most important part before building any CosmWasm contract, is to have a binary installed of Comdex so that they can interact with the testnet via CLI. So let's start with it. So the first part is to clone that Comdex repository. So we'll just take it and let's create a new window. Let's create a new window. Terminal. We'll just start with a terminal. And so let's actually make a directory. So we'll create a directory, workshop one, shop one, and let's cd into workshop one. Now we'll just git clone the complex repository. Sorry, git clone complex repository. Yes, so once we are done with cloning the repository, we'll just go into that particular repository, which was in Hackathon 1. Workshop 1. So it was in workshop 1. And you can see we have actually cloned this complex repository. So in the terminal, we'll just do cd comdex. And once we are done with this, we'll just check out into our brand, into our tag. So here the tag for the testnet is hack v1. So we'll first git fetch and then git checkout hack v1. So now we have actually successfully switched to hack v1. Now we actually need to install our complex binary into our local system. So for that, first we'll do the core mod vendor. And once we are done with this, we'll just make install. That will actually create your complex binary. On successfully installing our complex binary, we can just verify our installation by typing complex version, which should give you the tag that you actually installed, which is hack underscore v1. So this is where we have actually uh, perfectly installed our complex binary. Now the next step is to create, the next step is to interact with the test chain and see how it actually works. So, so for starting this, let's create a wallet. So to add a wallet, the command is complex keys add and your key name. So let it be the workshop one, or let's say user underscore one. Let it be my key. So it has actually generated my public key as well as address, and you can see the last thing is the mnemonics it has generated. Guys, do note that please store this mnemonics beforehand because you won't be able to retrieve it later. So since we have got our complex address right now, so let's request some faucet from here. So we'll just copy this address. We'll just go to faucet, faucet.complex.1. And in the drop down menu, you will see that we have a Nova net, which is our hackathon testnet. So we'll just paste our complex address and clear the capture and send tokens. So the faucet has requested for some test tokens. Now we have the binary installed in our local, and now we can easily interact with our test chain. So let's see how it's actually done. I'll just create a new tab here. And once we go to our instruction section, we can see that here are the chain details that are actually required to connect to the NovaNet test chain. So here is a chain ID and the RPC endpoints. So these are the two things that will actually require to interact with our chain via CLI. So let's start over it. So the first thing is comdex. So let's check our balance first. For the address we have asked the test tokens for. So that will be comdex q bank balances. By default, if you don't provide any node, it will be pointing to your local host. So since we have requested tokens for our testnet, so we'll be pointing it to our node, which is equals to our RPC endpoint. And complex queue bank balances, and the balance that we need to check is for the address that we had created, which is this. So here you can see the balances where I've actually got 1000 CMDX, and basically one CMDX is equals to 10 to the power 6 mu CMDX. So we have actually got our test tokens as well. Now let's try to look into how uh, different functionalities of a smart contract or a WASM module. So for that, I'll just I'll be explaining all those commands step by steps of how to identify it works. So let's start with comdex tx. So every time the first thing is our comdex binary, the tx stands for the transaction, whereas the q stands for query. So tx is supposed to be changing the state of a blockchain, whereas the q is only required to get data that which doesn't change any state of in any blockchain. So it will be comdex tx, and then the module name, which will be wasm, and let's provide a node as well. So it will suggest you all the commands available for the WASM module. So you can see that here is store, instantiate, execute, migrate, set contract admin, clear contract admin, grant, and update instantiate config. So I'll just tell you about them briefly, but we'll get to know more about all these functionalities when we start the development of our contract and use all those functionalities given here. So store, as you had as already mentioned, that it's basically to upload a WASM file into a blockchain, and it on successful uploading of that particular WASM file, it actually gives you a code ID, which is a count, which is kind of a counter variable that works on every contract upload. Instantiation is basic. Instantiation 1 and 2 is kind of similar and is basically focuses on of how to create a new instance of a specific code ID, and execution works only once the any code ID is instantiated with a particular contract instance. Here, one thing to notice is that whenever in Solidity, whenever we used to create some contracts and deploy it, and upon deploying and creating their instance of it, migrating it is kind of difficult. Here comes CosmWasm, where you can just straight away migrate a contract or a existing instance to a new code, and that can be done effortlessly. So the for that you actually need to be the admin of that particular contract you are actually migrating. So set contract admin works for that as well, and same, and the vice versa works for clear contract admin. Grant is something which allows you to grant some authorization to a different address who can run different transactions on your behalf based on how much power or the grant that you have provided for them to execute something in your position. Update instantiation config actually update for any code ID. You can actually set like who can instantiate that particular code ID and who cannot. So whether it's an address, whether it can be everybody, or whether it can be nobody. When it's actually a nobody, then it has to go through a governance proposal to instantiate that particular contract address. So this is the kind of a brief explanation of how CosmWasm transactions actually work and what are the key core functionalities of CosmWasm. So in the next workshop, we will be looking more into how to create a new project and what are the different key points in that particular project. And based on that, we will be writing a custom logic on that.